Hello everyone. We are the Group 4 and in today's lecture, we are going to introduce the idea of how we can generate and prepare actual earthquake time histories to use in a response analysis.
The Group 4. Kayla Cabrera,
Luz Francisco,
Joshua Magsino, Christian Pobly, Gila Sarmiento.
Time history analysis. It is the use of an earthquake time history to evaluate the response of the system. It can be performed for both structures and soil. Kadalasan nagpe-perform ng ganitong analysis ay ang mga structural engineers for structural design and geotechnical engineers naman sa soil analysis. And yung tinutukoy ditong system is yung ginawa nating design ng structural. Ito yung mga beams, columns, foundations, and ginagamitan natin siya ng actual time histories para malaman natin or makita natin kung ano yung magiging response niya. Kung magkakaroon ba ng major failure o hindi. So ano nga ba yung mga objectives natin kapag magpe-perform tayo ng time history analysis? Una dito is to characterize and gain insight into structural behavior. Pangalawa, generate information useful to the design decision-making process. So for example, si architect tapos niya nang gawin yung architectural design. And then after nun, dito na papasok yung structural engineer na magdi-design ng columns, beams, foundations, and other structural member. And then kapag nasa stage na siya ng analysis, so mag-a-apply naman siya ng mga actual time histories para makita kung ano ba yung magiging behavior ng structural design niya after niyang ma-apply yung mga actual time histories. And then kapag meron siyang nakitang major deflection or failure dun sa part ng, halimbawa lang dun sa cantilever part, so dun papasok yung decision making process niya. Kung ano ba ang dapat niyang gawin doon. Kung magkukonsider pa ba siya ng ibang factor para mapatibay yung structure niya? Or dadagdagan niya ng columns doon sa cantilever part, lalagyan niya ng support doon sa part na walang support para maging stable yung structural design na ginawa niya.
Next one is the two main methods to get time histories. The two main methods to get time histories are time history scaling and spectral matching. In time history scaling, it involves modifying a time histories and or in order to try closely match the design response spectrum. Time history scaling try to make the smooth average spectrum fall within a specified tolerance of the target spectrum. So, sa time history scaling daw, parang isa-isahin mo pa lahat ng records na meron ka. Tapos then mag-response spectrum ka. Tapos need mo pa i-match or kahit di ka katulad, basta malapit dun sa given na design response spectrum. So basically parang ang tedious niyang gawat. Madami kang need na i-consider. Tas ayun, mas prefer daw ng mas marami yung spectral matching. Tapos yung response spectrum pala, siya parang line graph siya. Tapos ang definition niya is a plot of the peak or steady state response, displacement, velocity, or acceleration of a series of oscillators of varying natural frequency that are forced into motion by the same base vibration or shock. yung response spectrum, di ba, line graph nga siya. So, yung may x and y, ano siya, axis. Yung sa x-axis, yung natural frequency. Tapos, yung sa y-axis naman, yung response. Yung response, dun yung parang yun yung displacement, velocity, or acceleration. Yun. Tapos, time history scaling advantages. It uses real-time EQ time histories, retains natural variances in the EQ time histories, and allows you to focus response on the period or periods of interest, and relatively easy to do with proper tools. So need pa daw ng proper tools. Sa disadvantages naman, it usually requires a lot of time histories. So yun nga, sabi ko nga kanina, parang need mo pa lahat ng records na meron ka. Tapos, it has a greater variance in the computed response, and it can take a lot of time to do. Yun, tedious masyado gawin. And next naman is sa spectral matching or time domain spectral matching. It involves a time domain modification of an acceleration time history to make it compatible with the user-specified target spectrum. It has the advantage of significantly reducing variability in the computed response because the time histories are often very close to the target response spectrum. So, dun sa spectral matching or time domain spectral matching, yun daw yung most commonly used technique in earthquake engineering to obtain accelerograms, for which the response spectrum is compatible with a smooth target spectrum, be it a polyline, design spectrum, or a hazard spectrum. Yun nga, sabi most commonly used technique in earthquake engineering daw to obtain accelerograms. Yung accelerograms ay yun yung the recording ng acceleration of the ground during an earthquake. Tapos, dito naman, parang yung mga nakuha mo na dun sa response spectrum niya. Yung response spectrum niya ay yung line graph. Na ang x-axis ay yung frequency, tas yung y-axis ay yung response, yung mga displacement, velocity, or acceleration. Tapos yun, yung mga nakuha mo daw doon, compatible dapat or pasok na siya doon sa given na design response spectrum. Kasi yung itong spectral matching na to, siya, it is utilized to scale the available real records obtained from the near fault motions and far fault motions to match the proposed elastic design acceleration spectrum given. Yun na. Tapos, yung next naman is yung advantages ng spectral matching. Advantages, it has less variability. It usually requires fewer ground motions. Sometimes easier to spot design flaws of the system response. So basically, kahit maiksi lang yung time, mas maiksi yung time na mag-google mo dito compared dun sa yung sa una, yung time history scale. Tapos ang disadvantages, it can result in unrealistic EQ ground motion. Certain valuable aspects of EQ time history can be lost, and it can take a lot of time to do correctly. Last is easy to screw up if you don't know what you're doing. So, yeah, thank you.
Selecting time histories. Part of the challenge of developing time histories is selecting appropriate time histories to use. Hindi pwede yung kung ano lang yung matripan mong gamiting histories or time histories, ayun na lang. Meron pa rin tayong dapat i-consider ng mga factor kung ano ba yung dapat nating gamiting time histories dun sa ating design. Ano nga ba yung mga factors na dapat nating i-consider pagdating sa pagpili ng time histories? Una na dito is yung magnitude. Ito yung mga anticipated recorded earthquakes na possible tumama doon sa structure natin. Example nito is yung mga building sa Maynila or malapit doon sa West Valley Fault. So, ang worst case scenario dito is magkakaroon ng the big one. Merong 7.2 magnitude earthquake na possible tumama doon sa West Valley Fault. So, possible na ang mga buildings doon is dinesign na ng mga structural engineer para makapag-resist ng 7.2 magnitude earthquake. So, pwede natin gawin yon sa mga structure na malapit doon sa West Valley Fault na pinapangambahang magkakaroon ng the big one. Pangalawa is yung distance. Dapat daw nasa within plus or minus 10 kilometers lang yung pagkukuhanan mo ng time histories, if possible. Pero halimbawa, isa kang structural engineer na naka-base sa Middle East and alam natin na ang Middle East is not an earthquake free. But yung mga earthquake doon is hindi na masyadong noticeable. Hindi na siya kinukonsider kapag nagdi-design ng structure. Ngayon, kung isa kang structural na naka-base sa Middle East, tapos kinonsider mo yung earthquake load na nangyayari sa area na nasa loob ng Pacific Ring of Fire, magiging uneconomical na yon. Napatibay mo nga yung structure, pero parang nonsense na din yung paglalagay mo ng or pag-consider mo doon sa earthquake load kasi nga, yung location ng structure mo is not earthquake prone. So, sayang lang yung ginastos mo doon sa aspeto ng pagre-ready doon sa earthquake na hindi naman tatama doon sa location ng structure mo. Pangatlo is yung faulting mechanism. Mayroon tayong normal fault, reverse or thrust fault, and subduction zone. Pang-apat is yung spectral acceleration na dapat nagre-range lang between 20 to 30%. And yung panglima is yung soil or rock type. Meron tayong 5 site class. Ito yung A, B, C, D, E na nandoon sa ASCE 7-16. And yung pang-anim is yung directivity effects if applicable. Saan nga ba tayo pwede makakuha ng time histories na pwede natin gamitin sa pag-analyze ng ating structural design? So, una na dito is yung mga website na pwede nating bisitahin. Una na dito ay ito. At pangalawa ito. Evaluating the results. Here are some things to look for. Una, plot the acceleration, velocity, and displacement for both pre and post match time histories. Kailangan lang nating makasigurado na yung mga significant peaks sa ating time histories ay hindi masyadong nabago. Pangalawa, make sure that the desired aspect of the ground motion are still there after the spectral matching. Pangatlo, compare the pre and post matching areas intensity plots. Kapag ang resulta o yung graph ay ganito na halos naka-line up ng ayos, na-retain yung shape, at naka-create tayo ng medyo maliit na deviation, ibig sabihin maganda yon sa analysis natin. Pero kapag ang graph o yung resulta natin ay halos hindi na magtugma yung dalawang linya at nakaka-create tayo ng mas malaking deviation, ibig sabihin hindi maganda yon sa analysis natin. Kailangan natin magdagdag ng konting adjustment para ma-achieve natin yung desired na outcome natin. Pero yung value ng deviation natin is nakadepende pa rin sa kung ano yung gusto natin na i-tolerate dun sa analysis natin. Spectral matching tips. Here are some tips to improve the spectral matching. Una, don't specify too high tolerance. If you are developing 7 sets of time histories, a tolerance of 20 to 30% should be fine. Ang tinutukoy ditong tolerance is gaano kalaking deviation ang iaalaw mo. Pero kapag ikaw ay nag-develop ng 3 sets or less, ang 10 to 15% ay okay na. At kapag mas tight yung tolerance na ginawa mo, ibig sabihin nun, mas mahabang time ang makikreate mo pag ikaw ay nag-a-analyze. Pangalawa, performing 2 passes will make your matching look better. Sa unang pass is yung 0.01 to 1 second. And kapag nagkaroon ka ng 1.1 second, doon na siya papasok doon sa pangalawang pass, which is the 0.01 to 10 seconds. Bukod doon sa mga website na pinresent ko kanina, meron din tayong mga software na ginagamit na meron siyang mga built-in na time history load na pwede natin gamitin sa time history analysis. CSI software handles the initial conditions of a time function differently for the linear and nonlinear time history load cases. Ang CSI, ito yung Computers and Structures Incorporated. Sila yung mga nag-develop ng mga mahalagang software sa pag-a-analyze ng structure. Ang mga software na dinevelop ng CSI ay SAP 2000 for Structural Analysis and Design, CSI Bridge for Bridge Analysis, Design and Rating, ETAVS for Building Analysis and Design, SAFE for Analysis and Design of Floor System, and Perform 3D, the performance-based design of 3D structures. Next one is CSI Plant for Pipe Stress Analysis and Design, CSI Cool for Design of Reinforced Concrete Columns. For BIM software naman or yung Building Information Model, nandito ang CSI Detail for Structural Detailing and Drawing Generation, CSI Rivet or Directional Data Transfer Plugin for Rivet, and CSI CAD for Drawing Generation Plugin for CAD platforms.
A load case defines how load patterns are applied statically or dynamically, how the structure responds linearly or nonlinearly, and how analysis is performed through modal analysis, direct integration, etc. For each analysis to be performed, a load case is defined. Each load case may apply a single load pattern or a combination of load patterns. An unlimited number of load cases may be defined. Then, any set of load cases may be selected for analysis. Once analysis has run, load case results may be selectively deleted or compiled for output reports. When selecting the best structural system, the load path must be determined. The load path is the route through the design that a load will travel when it is applied to the assembly. This is fundamental for the sizing of beams or members, components, and connecting elements. The load path may vary for a given design depending on the load case that it experiences. For example, dead loads, loads which are always present, example is self-weight, can subject a structure to a load path that is entirely different to live loads, externally applied loads, dynamic loads, wind, impact, and traffic loads, and exceptional loads, earthquakes, and misuse of equipment. Not only must the load path for each of the above classes of loading be considered when designing equipment, but the combination of these loads must be considered where necessary to ensure that the design is robust and fit for purpose. These loading requirements are not only driven by a client's specification, but mandated by legislation in the appropriate codes or standards for the design of the equipment. Therefore, there is a functional and legal obligation for the performance of equipment when under load. Specifications for each load case include case name, applied loading, and analysis type. Case name. A unique name is applied to each individual load case to index analysis results, displacements, stresses, etc., create load combinations, and possibly correlate with dependent load cases. Applied loading. Load patterns are applied to the structure. In some instances, however, load patterns are not applicable. Analysis type. Analysis type includes the method, static, response spectrum, backlink, etc., and the formulation, linear, nonlinear, etc. What is linear cases? Linear cases always start from zero. Therefore, the corresponding time function must also start from zero. What is nonlinear cases? Nonlinear cases may either start from zero or may continue from a previous case. A long record may be broken into multiple sequential analysis which use a single function with arrival times. This prevents the need to create multiple modified functions.
Good morning, everyone. I am Ms. Maria Francisco, and I will be continuing our group report. So, let's continue with nonlinear structural. Behavior may be associated with either geometric or material response, each described as follows. So, the first one is geometric nonlinearity. Concerns the p-delta effects associated with application of external loading upon the display's configuration of a structure. So from its root word geometric or geometry, it deals with the shape of the structure, changing or deformation, and it also required for some application like analysis of involving cables, arches, and shells which have different shapes. So let's proceed next. Next is material nonlinearity. Concern in inelastic structural response in which the behavior of a component, system, or connection deviates from initial stiffness, tangent characteristic, or linear elastic behavior. So as it's a material, it also deal with material ng kasama sa building. So, involves ito yung nonlinear behavior ng isang materials based sa current deformation niya or deformation history or yung mga past naging deformation ng isang structure, rate of deformation ren, temperature, pressure, and so on. Example nito, material models are large strain or elastoplasticity, and example nito is rubber and plastic materials. So next is linear versus nonlinear. So analysis type, dynamic, unlinear which is strength-based, nonlinear is static pushover. So dynamic, unlinear is response spectrum, and the nonlinear is time history. So yung linear, more on hindi siya nagkakaroon ng mga deformation, pero nagkakaroon siya ng mga small displacement. Hindi katulad ng nonlinear is nagkakaroon siya ng large displacement and elastoplastic materials. Therefore, yung mga superposition effect cannot be applied. So, kasi sa nonlinear, nagbabago or nagkakaroon ng deformation every time na magkakaroon ng earthquake. So, next is false nonlinear analysis, FNA. Is a model analysis method useful for the static or dynamic evaluation of linear or nonlinear structural systems. FNA is well suited for time history analysis and often recommended over direct integration applications. So, yung FNA is ginagamit siya para ma-compute kung gaano kalakas yung epekto or responses ng building sa isang earthquake para mabilis siyang ma-minimize yung effect niya or mahanapan ng solution para hindi na ganun yung magiging pinsala or magiging damage niya. So, yung next is during dynamic nonlinear FNA application, analytical model should A. Primarily linear elastic. Second is have a limited number of predefined nonlinear members, and the last one is lump nonlinear behavior within linked objects. So, during dynamic kasi, ito yung medyo hindi siya steady or medyo may mga movement. So, dapat itong tatlo would be consider para pa nag-a-analyze ng model para mas magiging madali siya or magiging efficient yung result. Next one is capacity design. It's a design process in which it is decided which object within a structural system will be permitted to yield or the ductile components and which objects will remain elastic or the brittle components. So, yung objective ng capacity design is to confirm a building undergoes control or in order to avoid collapse in design level earthquake. So, para hindi siya madaling kumulapse every time na magkakaroon ng earthquake. To control din para maging lessen din yung magiging damages sa infrastructure. As stated nga kanina, meron siyang dalawang components which is the ductile and the brittle components. So, let's proceed with ductile components are designed with sufficient deformation capacity such that they may be satisfied displacement-based demand capacity ratio. Yung brittle components naman are designed to achieve sufficient strength levels such that they may satisfy strength-based demand capacity ratio. So, yung ductile components can withstand repeated displacement without significant loss of strength. They may bend and deform but they do not easily break. So, yung mga ductile materials is yung mga strong or mahirap or ay yung mga included dito yung example is detailed reinforced concrete and structural steel na sadyang yun yung pinapatibay kapag gumagawa ng isang infrastructure. So, yung brittle components naman have limited capacity for inelastic deformation without losing strength. They break when they bend them. So, ang kaibahan nito, yung brittle, parang if magbe-bend sila, it tend to be break. Ito yung include nito yung glass, unreinforced concrete, cast iron, and unreinforced masonry na sadyang hindi sila gaanong matitibay at mabilis silang ma-destroy even kapag magkaroon ng isang earthquake. So, the next one is the efficiency of FNA formulation is largely due to the separation of the nonlinear object force vector RNL from the elastic stiffness matrix and the damp equation of motion as seen in the fundamental equilibrium equation of FNA expressed as this equation. Ito yung equation na ginagamit sa pag-compute sa FNA para mas mabilis, at tulad ganina nung sinabi ko, para mabilis makalculate or malaman yung intensity na kayang tanggapin ng building pa nagkaroon ng earthquakes.
Sir, meron po kami papapanood ng video po.
In this video, I'm going to discuss about the dynamic analysis, time history analysis. So for given seismic loads, how the structure behaves for the given time periods. Okay. So here already I have data regarding the time history analysis, and I'm going to use that file for this structure. Okay. Already we have done earthquake and response spectrum. Okay. So after that I'm going for time history analysis. Now we need to go for the define menu here and just go for function option. Okay. Already we have defined earthquake loads here. Similar way, we need to go for the functions, and we have to define the time history function here. There are predefined time history here, so you can just delete that one. We don't require that. Choose function type to add. So under this, we need to select the from file option and click add new function. So we need to browse that file. Okay. So actually by default, I have a file here. So I'm just going to browse that and I'm going to attach with the video. So you can check it out there. So just go for the browse and you can go for, like wherever it is. So you need to browse. Here I'm going to select the TH1. So just select open. And so we can see the linearly varying graph here. Okay. And click on OK. And whatever the data present in that file, all that will be considered for the structure analysis. So if you want to see the data, and yeah, you can open the text file, or let me show you here. You can click on view file and we can see the data regarding the time history analysis. Okay. So just I'm going to close this, click on OK and click on OK. After defining the function, we need to assign the load case for time history in X direction, Y direction. So just go for define option and click on load cases. Now just click on add new case and you can just rename it as suppose THX, for example, or you can define X and Y in the same case also. Okay, so let me define in two different cases. So that is under load case type, you need to select the time history instead of linear, and it is a linear model since we have seen the graph also. And click on add here and select the load pattern as select the load pattern under load type and select the load name as EQX, that is earthquake in X direction, and click on OK. So all the other options are same here, so click on OK. So similarly add new case and we need to go for THY direction and select the load case as time history here and click on add. So just select the load name as earthquake in Y direction and click on OK. So we got THX and THY. So click on OK to produce this. And after that, we can go for the analyze. So you can just check the model for any warnings or errors. So after checking the model, then we can go for the analysis. So just click on this option, or you can go for analyze and click on run analysis. Yeah. So after analysis, we can just get the base reactions for the TH and like support reactions, etc. And whatever the SFD, BMD we need. So suppose if you want to see the displacements for this, you can go for the deformed shape. And you need to choose the THX and THY. So at whatever time, or if you want to see the absolute max, you can go for the absolute maximum. Okay. So what is the maximum displacement occurred? You can click on start animation and it will be shown in X direction like this. Okay. So let me add another window. So just click on this and I'm going to click on add new window. And I will show the Y direction displacement here. So again, you can go for deform shape and select the THY and you can just check whether it is a minimum displacement or maximum or absolute maximum, etc. So click on apply and click on OK. So you can just go for the start animation. This will be represented for the Y direction like this. Okay. And this is for X direction. So this is how the building behaves for the maximum displacement for the given time history data. Okay. And if you want to see the shell stresses, etc., you can just click on this. And let me show you the SFD BMD, for example. I'm going to select the THX for the given time period or maximum and minimum value. So whatever option you want to keep, just select that one and select whatever you want to represent. So just click on apply. So let me stop this animation here first of all and click on apply. OK. And we got the maximum forces of this object. So let us refresh this again. So just go for the spandrel forces, I mean like frame forces, and you can select the time history in X direction. Either you can check for time with respect to time or maximum minimum values or only maximum or only minimum. So for example, at time period something around 0.8 seconds, what is the moments developed? Okay, so if you want to see the maximum moments developed, and if you want to see the values, you can just click on this one, show values at controlling stations. Okay, or else if you want to see for 5 seconds, just type the 5 and click on apply, and there is some change in the moment graph there. Okay, so like this you can check for shear direction, I mean shear forces and BMD, etc. And similar way we can check for 3D also, I mean like in 3D view we can check the shells also. So I'm just going to click on the shell forces, and depending upon time or maximum displacement, you can just go for the either maximum values like maximum shear. So click on apply. We are going to get some contour here. Let us check for maximum moment. So click on apply. So for maximum moment at 0.2 seconds, this is the value. You can just check the values with respect to contour. And if you want to see the show maximum moment or minimum moment as arrows. Okay, so if you want to see that arrow flow there, so what is the minimum and maximum values? Let me keep this in the top view. So just going for the plan view and story 13, we are going to see the story 13. Okay, so these colors are indicating the minimum to maximum values, and according to that you can observe the arrow marks on the structure. Okay, or if you want to show fill, you can go for the show fill option and click on apply. So accordingly we are going to get the show fill. Okay, so just removing the arrow marks, you can just go for the show fill. Let us check for around 4 seconds what might be the results. So click on apply. So there is some small variations, and similarly for Y direction, let us take for Y direction and click on apply. So accordingly, I mean with respect to direction, we are going to get the results. Okay. And for example, if you want to see the absolute maximum, you can go for absolute maximum. And similarly, if you want to go for only maximum value, you can click on maximum. Okay. So there is no particular value there. Only with respect to time, we are going to get the values accordingly. Okay. So let me keep time again, and just you can check for 2 seconds, for example, to apply. Okay. So it might be varying from floor to floor. If you want to show lines kind of thing, you can just activate the lines here. And if you want to show the values, you can click on show values. Okay. So at 2 seconds, there is no stress, I mean like no movement for this. So click on apply. For different time periods, for the there will be different stress developed there. Okay, so you can go for 3D and just cross check with the stress and stress contours given below. Okay, so this is all about the time history analysis.
Last part na po to.
Last part of our report, the time history analysis facts. A time history analysis is a step-by-step analysis of the dynamic response of a structure to specified loading that may vary with time. Time history analysis is used to determine the seismic response of a structure under dynamic loading of representative earthquakes. The first question for time history analysis facts is, what value of scale factor should I use to define a time history load case? First is the load pattern. When load type is set to load pattern, the values of the time history function are multiplied by the scale factor to produce unitless terms. Here, the record should describe the variation in loading over time as applied in the load pattern. Second is the axle. When load type is set to axle, the scale factor should be specified such that it multiplies with the values of the time history function to produce the acceleration desired in the current units. Here, if the values of the time history function are given in the current units, the scale factor should be set to 1.0. Otherwise, the scale factor should reflect the conversion from the units of the time history function to the current units. Question number 2. What forces are included in reactions from time history analysis? Reactions include only the effects of elastic and possibly inelastic forces unless links are connected to joint locations, in which case the damping forces within link objects are included during computation of joint reactions. Question number 3. What value should be specified for the output time step size during time history analysis? Output time step size should be small enough to provide sufficient resolution for analysis. The required resolution is dependent upon the characteristics of applied loading and such structural properties as the natural periods. The sufficiency of resolution may be determined by decreasing the time step size until it is small enough to not affect results. Question number 4. Can I specify different time step sizes for different phases of the time history analysis? Time step size is fixed for a given time history analysis. However, a series of nonlinear time history analyses may be defined with variable time step sizes, then these analyses may be chained together. Last is the question number 5. What is format type and arrival time? First is the format type. Format type options indicate how data is presented in the time history function text file. There are two types of format. First is the free format. This is applied when spaces or tabs separate the data. Second is the fixed format. Fixed format is applied when data is not separated by spaces or tabs. In this case, the number of characters per item should be specified in the edit box. And lastly is the arrival time. Arrival time is the time at which a load assignment begins. This value may be positive, negative, or zero. Time history analysis always begins at time zero for a given load case.
Sir, tapos na po. Meron din po kaming quiz. Sisend ko yung dito sa chat. Wait pa tayo ng iba. Start ko na po. last na po yun. Danger po yung first case. I-PPM na lang po namin kayo. Okay na po, sir. Thank you po.